Hello, in this video I'm going to teach you a little bit about what is discontinuity in math. So what is discontinuity? A discontinuity is a point at which a mathematical object is discontinuous. A function has a discontinuity if it isn't well defined for a particular value or values. Discontinuities can be classified as jump, infinite, removable, and essential. So what are removable discontinuities? Well, they are characterized by the fact that the limit exists. They can be fixed by redefining the function. Here we have an example of a piecewise function. The first part, 1, x has to be bigger than 0. In the second part, x has to be minor than 0. This example does not have a continuous derivative. The function is continuous at 0, so it has no derivative at 0. The discontinuity of x at 0 is a removable discontinuity, shown here by the graph. In the second example, we have that x cannot be 1. In the second part, x has to be equal to 1. In particular, f has a removable discontinuity at x equal 1, due to the fact that defining a function f(x), as discussed above, and satisfying f(1) equals 2, would yield an everywhere continuous version of f, shown here also by the graph. Jump discontinuities. They are both one-sided limits exist, but have different values. The graph of f(x) below shows a function that is continuous at x equals a. In this graph, you can easily see that the limit f(x) equals L and limit f(x) equals M. Another example will be this one. Here, the value of the function is not defined at x equals 0. For all values of x which are bigger than 1, the function gives 1. On the other hand, for all values of x that are smaller than 1, the function returns to -1. Here shown in the graph. The next type of discontinuities are infinite discontinuities, where both one-sided limits are infinite. Here we have an example of a piecewise function, where x cannot be 0 in the first part, and the second part, x has to be 0. Here we can see in the graph that both sides are infinite. They never touch, and they have an asymptote at a. In our second example, we have 1 over x minus 1. They have an asymptote at 1, and they never touch. Both sides are infinite. The next type is an essential discontinuity. At least one of the one-sided limits does not exist. Here we have an example 1, where x to the square if x is minor or 2. At x equals 2, there is an essential discontinuity because there is no right side limit, shown here in the graph. Our second example is 4 if x is equals or is bigger than 2. At x2, there is an essential discontinuity because there is no left side limit, shown here in the graph.